All right, welcome back. Welcome back. Let's keep it moving. I'm going to try and keep this video under 5 minutes. So here we go. All right, so here is a graphic organizer. If you remember last year, you were introduced to rational numbers. Okay, that was the large set or the largest group of numbers. So every number you saw last year was a rational number. Within that rational number set, you had some subsets. One of those subsets was whole numbers. Another subset was integers. And then that last subset was your natural or your counting number. So this is all a review of last year. We're going to go over these definitions in just a second. So if you look, there's only two new things that you're being introduced to. The main thing is what we call irrational numbers. So all the numbers you see in the 8th grade are either rational or irrational. So when we're talking about rational and irrational numbers, they make up a larger set that we call real numbers. So every number you see in the 8th grade is a real number. And so we just need to figure out if that real number is either rational or irrational. So let's talk about how we do that. So here are your definitions. I'm not going to spend a whole lot of time on set and subset. Just remember, set is a group or a group of numbers. Subset is a group within a group or a smaller group of numbers within a larger set. So in the 8th grade, every number you see is a real number. And inside of that real number system or that real number set, we have rational numbers. So this large rectangle over here. Inside of that rational numbers rectangle, we have integers. So since this integer rectangle is a little smaller than rational and it's inside, that means every integer is a rational number. Then we have whole numbers. So all your whole numbers are also integers and also rational numbers. And then last but not least, we have your natural numbers or your counting numbers. So every natural number is a whole number, which means it's also an integer, which means it's also a rational number. So if you look, we've got this blank square or rectangle over here to the right. That is our irrational number. So these are separate from rational, okay? So no irrational number can be rational. It is separate. So let's go over our definition. So we've got, the first one says counting numbers from 1 to infinity. So when we're counting 1, 2, 3, 4, 5, 6, 7, all the way to infinity, we call those our natural or our counting numbers. Then we have all natural numbers and zeros. So if we have all our counting numbers, now we're adding 0. We know those are our whole numbers. Our third definition, all natural numbers, they're opposites and 0. So all natural numbers are counting numbers. They're opposites, which means negatives, and 0. Those are our integers. So now let's talk about fractions and decimals. So any number that can be written as a fraction, including terminating. Okay, that's important. That means it ends, it stops. Okay, so terminating decimals and repeating decimals. So if it's a pattern, so 1, 2, 1, 2, 1, 2, or 1, 2, 3, 4, 1, 2, 3, 4. If it has a pattern or if it repeats or it stops, it terminates, that is a rational number. So now the opposite, basically the opposite of that. So any number that cannot be written as a fraction, including non-terminating, non-repeating, and imperfect squares, we call irrational numbers. And then the set of all rational and irrational numbers are our real numbers. Incredible, huh? So here's our real number system. If you look at the top, I'm going to run through these real quick. So we've got a set of numbers here. So the first one is negative 19. Negative 19 we know is an integer. That's a negative whole number, right? So that is an integer. Square root of 121. If I put that in my calculator, I get 11, which means it's a counting number. Negative 6 is an integer. Again, negative 75. If I put that in my calculator, I get a non-terminating, non-repeating number, which means it's irrational. 12/5, that is a rational number. That is a terminating or repeating decimal. 0, we know, is a whole number. Pi, remember pi, that number goes on forever. It does not repeat. That is an irrational number. And 2/7 is a rational number. I hope you guys enjoyed this. Make sure you complete your assignments, and I will